Mechanics, linear motion book. Please write a small theory part. I don't remember whether we have discussed this earlier or not. So whatever, please write the subheading displacement in nth second. Write the subheading as displacement in nth second. Nth second. Displacement in nth second. It's right. Let us consider an object. Let us consider an object. Let us consider an object which is traveling along a straight path. Which is traveling around a straight path with a constant acceleration. Let us consider an object which is traveling along a straight path with a constant acceleration. With a constant acceleration. Look at what it. Let's say this object starts to move with the velocity of u meter per second. Its acceleration is a meter per square seconds. Let's say after 9 seconds, for example, its velocity is v1. So what is the velocity after 9 seconds here? v1. I'm trying to explain the story, the theory behind the picture. After one more second, its velocity is v. So what is the total time duration then? 10 seconds. Am I right? So the total time duration is 10 seconds. Am I right? It travels from A to B within 9 seconds, B to C within 1 second. A to B acceleration simple A, B to C also acceleration simple A. Means object travels with a constant acceleration. Right? If I can write this 9 as total time 10. I can write 9 as 10 minus 1. Am I right? So what's the time taken for the object travel from A to B? 10 minus 1, 9. What's the time taken for the object travel from B to C? 1 second. This 1 second is the 10th second. Am I right? A to B 9 second, B to C is the 10th second. Am I right? So if I mark B to C displacement as S2, what is S2 then? It is the displacement during the 10th second. Okay or no? If I mark displacement from A to B as S1 meter, what is S1 meter here? S1 is the displacement for the first 9 seconds. S1 is the displacement during the first 9 seconds. S2 is the displacement during the 10th second. Clear or not? Clear. Right. Without writing 10, if I change this as n seconds, then how the other numbers change it? 10 minus 1 is 9. Now 10 is n. And this is n minus 1. If this is n minus 1, this is the nth second. Am I right here? If n is 10, this is the 10th second. If n is 10, this is n minus 1, 10 minus 1, 9. So this is the n second. So therefore S2 is the displacement during the n second. Got it? Displacement during the n second, let me take it as Sn. So what is Sn meter? Displacement during the n second. Is it clear? Draw the figure. Right. So what should we do next? We'll apply the equations that we know. A to B. Look at board. Do not write anything. Just look at board. I promise I will not erase anything. Just look at board. A to B. I apply the equation. I indicate the direction because I am working with vectors. A to B. I apply the equation S equal UT plus half AT square. A to B displacement is 1, initial velocity u, time is n minus 1. If n is 10, what is n minus 1? 9. Half, acceleration is a, t is n minus 1. You remember O-level maths here, what is x minus y squared? X square minus 2xy plus y square. Therefore, what is n minus 1 square? N square minus 2 into 1 sorry 2 into n into 1 x square 2xy 2xy plus y square. Y is 1, x is n. Am I right here? I have taken x as n, y as 1. X square means n square. 2xy means 2xy, n1. Y square means 1 square. Clear or not? So I use it here. So S1 equals U into n minus 1 plus 1 into A is A over 2. N minus 1 square means, please don't write, n square minus 2 n1. X square minus 2xy plus y square means square of 1. Can you remove the brackets and simplify this? Remove the brackets. So if you remove the brackets, you get u into n is un. U into 1 is minus u plus a over 2 into n square plus into minus minus a over 2 into 2 n1 a over 2 into 2 n1 plus 1 square is 1 a over 2 into 1 square. Am I right here? So what's the final equation? What's the final equation? I'll write the final equation here. So S1 equal, is it possible to cut any terms? UN, I don't find any UN term. Ne? Minus U, n square over 2, no. Ne? So UN minus U plus an square over 2 minus 2 and 2 cancelled out a plus a over 2. Am I right? Can we cancel out even a single term? Right? Who got this expression? Name this as equation number 1. name it as equation number 1. Now let us apply the same equation. Let us apply the same equation from A to C. Not B to C, but A to C. Straightforward. A to C along the horizontal direction is equal to UT plus half AT square. Look at board, don't write. So what is the total displacement from A to C? S1 plus S2. Total displacement is S1 plus S2. U is U. A to C total time is N. You see, A to C total time is N. A to C total time is N seconds. N plus half acceleration is N. A time is N square. So what will you get? S1 plus S2 equals UN. NA into N is N square divided by 2. I'll take plus S1 to the other side as minus S1. So S2 equals UN plus N square over 2 minus S2. Mark this as your second equation. Write it. Finally, we can combine them. I'm going to combine 1 and 2 equations. Look at board here. From 1 and 2 equations. Let me write the second equation first. S2 equals UN plus N square over 2 minus S1. Right? S2 equals UN plus an square over 2 minus, when there's a minus sign, you must open the bracket. So what is S1? S1, see, a lot of terms there. According to first equation, S1 is un minus u plus an square over 2 minus an plus a over 2. Am I right here? In the place of u S1, I have written the expression of S1 from the equation number 1. Can you simplify? Now remove the brackets and simplify it. Right? Simplify this. So if you remove the brackets, I think we can cancel out a lot of terms. S2 equals un plus an square over 2 minus into un minus un minus into minus plus u minus into positive minus minus into minus plus, either way, minus into positive minus. I will check how many terms that can be cancelled out. Just look at, check it out, remove the brackets properly by multiplying with the minus sign and check how many terms that can be cancelled out. We can cancel out plus un minus un cancelled out. An square over 2 minus an square over 2 can be cancelled. That's all. So what are the remaining terms after you have cancelled out un and an square over 2? What are the remaining terms? What are the remaining terms? S2 equals u plus a minus a over 2. Okay, dear? So those are the remaining terms. I can simplify this. u plus, I can write an as an into 1. Any difference there? No difference. Why? A into 1 is A. Now I can write u plus an. In the place of 1, I can write 2 over 2. 2 over 2 is 1. 1 into A. 2 divided by 2 is 1. 1 into A is A. No difference. Now u plus, I can take this 2 and A. No, I can take this A over 2. A over 2 can be taken out from a bracket. So what are the remaining terms here? Here n, here, sorry, here n and 2. It means 2n. Got it? S2, what is S2 dear? Check the figure. S2 is the displacement during the nth second. So S2 is Sn. It means Sn equals u plus a over 2 times 2n minus 2. Who wrote this equation earlier than me? Recheck. Check all the calculations. Right, now let's try for a numerical example. After that, I'll start discussing some past paper questions. Please write example number 1. An object starts to move with a velocity of 3 meters per second. An object starts to move with a velocity of 3 meters per second. With a velocity of 3 meters per second. Along a straight path, along a straight path, along a straight path, with a constant acceleration of, 2 meters per square seconds. With a constant acceleration of 2 meters per square seconds. Find its displacement during the 3rd second. Find its displacement during the 3rd second. An object starts to move with a velocity of 3 meters per second along a straight path with a constant acceleration of 2 meters per square seconds. Find its displacement during the 3rd second. Now look at what is the initial velocity? 3 meters per second. What is the acceleration? 2 meters per square seconds. What is the thing that they have asked? Displacement during the third second. It means n is 3. Stop writing. If according to this figure, the total time is 3. N is 3 seconds. So n minus 1, what is this here? 3 minus 1, it means 2 seconds. So S1 is the displacement during 2 seconds. 2 seconds plus 1 is 3. Therefore, this is the third. The question asks us to find what the S2 is. Got it? Draw this figure. In the exam, no need to draw a figure, but let's draw a figure now. It will help all of us to understand this. What is the easiest method to answer this here? Let's say you don't remember this equation. Let's say you don't know this equation. Then how do you answer this question? You do not remember this equation. Isn't there any other way to answer? So simple. Just write A to B into the right hand side direction is equal UT plus half AT square. A to B displacement is 1. A to B in AB section, initial velocity 3, time is 2, plus half, acceleration 2, time is also 2, and square of that. Can you find S1 here? Can you find A to B displacement? 3 times 2. 3 times 2 is 6. 2 and 2 cancelled out. Square of 2 is 4. 4 plus 6 is 10. So S1 is 10 meters. Displacement of the object during the first 2 seconds is 10 meters. Who got this answer? So simple. Now just apply A to C. What's the equation? No need to know this equation, right? A to C is equal ut plus half A square. In AC section, A to C total displacement S1 plus S2. A to C displacement S1 plus S2. A velocity 3, time is 3. Total time taken for the object to travel from B to C is 3 seconds. Plus half, acceleration is 2, time is 3. Can you do the rest and find S2 from this? S2 is the thing that you want to find. Displacement during the nth second. Third second, that is S2. You just want to find S2. Do it. Right. S1, we already know. S1 is 10 meter, we know. Displacement during the first 2 seconds, 10 meter, we know it. 10 plus S2 is the displacement during the third second. 3 times 3, 9, 2 and 2 cancelled out. Square of 3 is 9. So 10 plus S2 equals 9 plus 9, 18. So S2 equals 18 plus 10 comes this side as minus 10. Therefore S2 is 8 meters. Therefore, the displacement during the third second is 18 meter. Sorry, 8 meter. Displacement during the third second is 8 meter. Who got this answer? That's it. Right, now let's check whether we are able to get check whether we are able to obtain the same answer by using the equation. So please write second method. Second method. Second method, apply this equation. Is n equals u plus a over 2 into 2n minus 1. Remember that here n, letter n is used for the time. N equal 3 means third second. Right it? Right, Sn, initial velocity is 3, acceleration is 2 over 2. The time is 3 seconds. During the third second, I want to find the displacement during the third second. It means n is 3. It's simplified. This is 3. 2 divided by 2 is 1. 2 times 3 is 6. 6 minus 1 is 5. 3. 1 into 5 is 5. 3 plus 5 is 8. So whatever the method you use, you get the same answer. That's it. Let's try for this MCQ, a past wave MCQ. This is given in 1980. AL, this is a MCQ question. Question number 12. I think it's a one sentence, single sentence question. So let's write the question. I'll read. An object at rest. An object at rest, comma, starts to fall freely under the gravity. An object at rest starts to fall freely under the gravity. Full stop. After 4 seconds, comma, its velocity, after 4 seconds, velocity and the distance traveled within the 4th second, and the distance traveled within the 4th second are respectively. After 4 seconds, its velocity and the distance traveled within the 4th second are respectively. Look at both. Look at both. And objects start to fall freely under the gravity. So it means initial velocity is c. After 3 seconds, its velocity is v1. After one more second, its velocity is v2. Look at both the. So what is the starting position of the motion? A. After 3 seconds, it is at B. After one more second, it is at C. Am I right? The question asks us to find V2, velocity after 4 seconds. 3 plus 1 is 4. Right? This is 3 seconds. This is 1 second. So what is the total time then? 4 seconds. Am I right? Total time is 4 seconds. So displacement, this is 3, this is 4. Therefore, displacement during the 4th second mean S2, B to C. S1 I don't know and they don't ask. So we will find S2 and V. Draw the figure. But as is the very old question, value of simple G should be used as 9.8. This is a very old question and no need to simplify the final answer. You can keep answers with 9.8. Right now, so simple. V2 can be found at once. Let me use this equation and find S2 as at once. Sn equals U plus A over 2, 2n minus 1. I'll use this equation at once because it's an MCQ. I won't find this S2. S2 equal initial velocity 0, gravitation acceleration. This is a very old question, so they do not use 10, they have used 9.8. Into 2, time is, I want to find the displacement during the 4th second. It means n equals 4, displacement during the 4th second. So n equals 4 minus 1. So I don't worry about 0, no need to divide, this is just 9.8 divided by 2. 2 times 4, 8, 8 minus 1 is 7. So displacement is this. If you want, you can write S2 equal half 9.8 into 7. Unit case. So this is the answer given in the answer state. So no need to simplify. Complete. Right. Then V2. What is V2? What should we do to find V2? Apply V equal U plus AT vertically downward. Vertically downward. V equal U plus AT, A to C. A to C. A to C total time 4. At point C velocity V2, at point A velocity C2. Final velocity 0, initial velocity. Final velocity v2, initial velocity 0, acceleration 9.8, time is 4. Therefore, v2 equals 9.8 into 4 meter per second. So now we know the velocity after 4 seconds and we know the displacement during the 4th second. That's it. That's the answer for 1980 AL MCQ paper question number 12. Write them on. Right, please write. This question, this question also given in 1980 AL MCQ number 13. I'll read the question. You should write the question. I'll read it. A child sitting on a train apartment. A train apartment means what's it? A child sitting on a train apartment which moves in a constant speed. Come on. A child sitting on a train apartment which moves in a constant speed. Come on. Throws a ball vertically upward. Throws a ball vertically upward. Full stop. If he faces the direction of, if he faces the direction of, if he faces the direction of the motion of the train, if he faces the direction of the motion of the train, comma, if there is no wind inside the apartment, if there is no wind inside the apartment means box, the box in which the man is sitting. If there is no wind inside the apartment, come on, which of the following statements is true? Which of the following statements is true? Okay. Number 1. Ball falls behind him. The ball falls behind him. What's the first answer? The ball falls behind him. Okay. Number 2. Number 2. Ball falls in front of him. The ball falls in front of him. Number 3. The ball falls to his left. It goes up, it falls to his left hand side. Number 3, ball falls to his left. Ball falls to his left hand side. Man. Number 4, the ball falls to his right. The ball falls to the right hand side part of the ring. The number 4, ball falls to his right. Ball falls to his right. Number 5, the ball falls onto his hand. The ball falls onto his hand. Now read the question and try to determine the answer. Try to find the answer without my help. Read. I'm going to ask you 2 questions. I'm going to ask you 2 questions. Before I answer the question, I am going to ask you 2 questions. Look at body. This is the train apartment. Many wheels will be there. This is the railway track. Question tells us it travels with the constant velocity. There is a boy. What does the boy do? He is at rest. He throws a ball vertically upward. He throws a ball vertically upward with a certain velocity. The question asks what will happen to the ball. My first question is this boy at rest? If the velocity of the train is u meter per second, boy is also moving with the same velocity. My second question is I am at rest? No, why? I am on the earth. Earth is rotating with a constant angular velocity. And earth is moving around the sun with a constant angular. Actually, that angular velocity is not constant, but the earth is moving along a circular path. As I am on the earth, am I at rest? Earth is moving, so I am not at rest. You can assume that earth is moving with a constant velocity. I don't have a ball, but I have a pen. I throw the pen upward. Look at the pen carefully. A magical pen. What has happened? It falls. I take the clip of the pen. I throw it up. It falls back to my hand. Am I at rest? No. I am moving with the constant. I am at rest on the stage. Yes. I am at rest on the stage. The stage is on the earth. Earth is moving with the constant velocity. It means I am also moving with the constant velocity. I throw an object upward, it falls back to my hand. Same here. This is moving with the constant velocity. The boy is at rest inside the box. As the box is moving, he is also moving. So if he throws something upward, same thing happens like this. So the ball falls back to his hands. The reason is, if the velocity of the train is u, what is the velocity of the boy? U. What's the velocity of the ball? That's also u into the horizontal direction. So both are moving into the same direction with the same velocity. Therefore, ball falls back to his throwing, falls back to the hand. So what's the correct answer? Answer is 5. Think and draw the figure. Please write below the figure. Please write both train, boy and the ball. Three of them. The train, boy and the ball are moving along the same path into the same direction. The train, boy and the ball are moving along the same path into the same direction. With the same horizontal velocity. Therefore, the ball falls back to the hand of the boy. Hands of the boy. Therefore, the ball falls back to the hand of the boy. Am I right? The train has the 10 meter per second velocity. Ball also have the same velocity if u is 10. So it throws the pen up, it falls back. That's it. Okay, dear? Right. Then let's try the next question. This is given in 1981 AL MCQ paper, question number 55. 1981 AL, question number 55. I'll read the question, you write it. Ball X is projected vertically upward. What's the name of the ball? X. Ball X is projected vertically upward. Full stop. After 2 seconds, a ball Y is projected vertically upward from the same place with the same initial velocity. Ball X is projected vertically upward. Full stop. After 2 seconds, a ball Y is projected vertically upward from the same place with the same initial velocity. Leave a line and write, consider the following statements. Consider the following statements. Consider the following statements. Leave a line and write capital A, circle it. Capital A statement. X and Y meet 5 meters below the highest point. X and Y meet 5 meters below the highest point. X and Y meet 5 meters below the highest point. Capital B. Capital B. When X and Y meet, the velocity of X is 10 meters per second. When X and Y meet, the velocity of X is 10 meters per second. 10 meter per second. See, whatever the time difference between the two balls, whatever the time difference between the two balls, comma, whatever the time difference between the two balls, comma, the speeds are equal at the instant, whatever the time difference between the two balls, comma, the speeds are equal at the instant when they meet, at the instant when they meet, at the instant when they meet. So we want to check we want to find the correct statements. Read the question and try to find the correct statements. I'll discuss, but before that you also give a try. Initial projected velocity is not given. Am I right here? Question tells us, right? An object is thrown from a certain height with a velocity of u meter per second. Am I right? After 2 seconds, what will happen? After 2 seconds, another object is thrown up with the same velocity. Am I right? When the second object is thrown, the first object may be somewhere here. It is moving up. If we wait another time, if we wait another t seconds, the first object may have reached the highest point and is moving downward with the velocity of v1 meter per second. And let's say second object also reached this point, but its velocity is v2 meter per second. Got it? So what's their heights? What's their heights from the initial projected point? That is h meet. Okay, so they meet after first object travels 2 seconds, t seconds, and reach will be there. Second object has traveled only t seconds and it is at this position. Clear? So if the projected point is capital A, if the projected point is capital A, the two objects meet at B. When the second object is projected at A, first object may be at a place something C, and we don't care about this. Okay, dear? So this is the position. This is the position of first object after 2 seconds. We do not worry about this. We don't worry about the position of the first object after 2 seconds. We worry about the time at when they meet. Draw this figure here. Draw it. Right. Look at both here. So what is the total time taken for the first object to reach to the point B? Actually, the first object has reached its maximum height and has fallen downward. That's why it has a downward velocity. When first is moving up, second cannot reach to the first one. Right? They do, as the second object does not have an engine, as both are moving freely under the gravity, first object should reach the maximum height and reach the point B, and then second one will reach to B and they meet some like this. Right? So if I draw the path followed by the first object we have traveled like this. Okay, that's what has happened to the. This is the first object. Second object directly travel to B, like this. So my question is, what's the total time taken for the first object reach to the B? 2 seconds and another 3 seconds. Got it here? What's the time taken for the second object to reach to the B here? Only 3 seconds. Got it here? Would like if I explain it again? Okay, we'll write, then you will understand. Let's write. Statement. The time taken for the first object. The time taken for the first object reach to the point B. The time taken for the first object to reach to the point B equals 2 plus T. 2 plus T. Am I right here? Now look at both. Look at both. To the first object A to B, right? Vertically upwards, I apply the equation V equal U plus E. I am applying the equation vertically upward, but what is the direction of the velocity of the first object here? Down. I am applying the equation upward. Why? Because I projected upward. Okay. Therefore, the direction of the equation and direction of velocity opposite. So I will get a minus sign. I don't like it, so I don't apply it. Right? At the very beginning, if I get a minus sign, I'll apply the other one. S equal ut plus half a square. Now both will be positive. So when the object is at B, it is at a vertical height of hp. So what is the displacement? Displacement is not the path followed. Displacement means straight line distance. Distance to the starting point and the point B along a straight line path. We don't care about the path followed by the particle. So displacement is h. Initial projected velocity, I apply the equation upward. U is also upward now. Happy. Both are positive. Total time is 2 plus t. Plus half upward acceleration minus g. Total time is 2 plus t. Now look at both here. H equal u into 2 is 2u. Lamai. U into t is ut. Minus into positive minus g over 2. 2 plus t square. That is x plus y square similarly. So this is x square. X square plus 2xy plus y square. X square plus 2xy plus y square. Okay, dear? So what will I get? H equal to u plus ut minus g is 10 over 2. 10 over 2 means 5. 2 square is 4. 2 times 2, 40. This is t square. Remove the brackets, try to simplify this. Remove the brackets and try to simplify this. So if we remove the brackets, we will obtain H equals 2U plus UT minus into 5 times 4 minus 20. Minus into positive, this is 14. Minus into positive minus 5 times 4, 20, 20t. Minus into positive minus 5t square. Can we cancel out even a single term? Can't we? Can no, can't. So let's name this as equation number 1. Who got the equation like this? Right now, write a statement. Next statement. The time taken for the second object reach to the point B. The time taken for the second object to reach to the point B equals simple T. Am I right? First one thrown after 2 seconds, second one thrown. After t seconds, they meet. It means the second object has traveled only for a period of t seconds. Okay. So leave a line below this, leave a line and write the statement. The time taken for the second object to reach to the point B equals simple t seconds. Put the equation mark and write equals simple t seconds. Simple t seconds. Now let us apply to the second object. To the second object, A to B, vertically upward is equal UT plus half AT square. The second object is reaches to B, it is also at a height of h meter. When the second object reaches to B, it also at a height of h meter. So displacement of the second object is also h. Its velocity is u time is t plus half. Gravitation acceleration is 10. This is no. What is gravitation acceleration here? Minus t. Up moving upwards. So it should be minus g. Minus g. Time is t square. So h equals ut plus into minus. Minus g is 10. 10 divided by 2 is 5. 5t square. Mark this as the second equation. Now we have obtained for the displacements of the objects when they meet. Right there. What do you think about 1 and 2 equations? Both 1 and 2 equations give H. H equals something, H equals something. It means 1 and 2 equations are equal. So simply I can write the second equation is equal to the O. First equation is equal to the second equation because both gives H equal. First equation is 2U plus UT. 2U plus UT minus 20 minus 20t minus 5t square equals UT minus 5t square. UT minus 5 square. Now I stop writing this to get code. Now we can cancel out many of the terms. What are the terms that can be cancelled out here? UT and UT. Minus 5 square to minus 5 square can be cancelled out. So what are the remaining terms here? 2u minus 20 minus 20t equals 0. All the terms can be divided by 2. In a u minus 10 minus 10t equals 0. Am I right? U equals minus 10 go to the other side as plus 10 and this also go to the other side as plus 10. Can we do anything for this here? Right. Before this object, before the first object reaches to B, where should it be? It should have reached to the maximum height. So, if I consider that motion separately, if I erase all these things because now I have used them all. If I consider only the motion of the first object, if I consider only the motion of the first object, look at board, its velocity is u meter per second, it reaches to its maximum height. At the maximum height, velocity is 0. So what is this there, Lamai? H max. Time taken for the object to reach the maximum height, let me take it as capital T. So projected point is A, maximum point, let me take it as D. Now what can we do here? We can apply an equation A to D. I can apply the equation V equal U plus AT. At the maximum height, velocity 0, initial velocity U, upward acceleration minus G, time is T. Minus gt come this side as plus gt equals u. Am I right there? So it means g is 10. 10 times t equal u. This is 1, 2, 3, 4th equation. This right. Let us consider the maximum height reached by the first object. Let us consider the maximum height reached by the first object. Draw the figure and obtain equation number 4. Draw the figure and Obtain the equation number 4. Right here. What do you think about 3 and 4 equations? 3 says u equal 10t. Sorry, 4 says u equal something. 3 also u equal something. It means 3 and 4 equations are equal. Third and fourth equations are equal. Am I right here? Am I right? So third equation tells 10 plus 10t equals 10 capital T. U equal 10 capital T, U equal 10 plus 10 simple T. 10, 10, 10 can be divided. 10 divided by 10 is 1, 10 divided by 10 is T. This is T. It means 1 equals, to take simple to the other side, capital T minus simple T is 1. What does it mean? What's the meaning of this? Think. The meaning of this is capital T is the time taken to reach the maximum height. Simple T is the time taken to reach the height h. So it means T minus T 1 second mean, look at board, first object travels to the maximum height within capital T. Within just after 1 second, it reaches to B. And at that time, second object reaches to B within simple T seconds. This is the meaning of T minus T is 1 second. I don't know whether you can understand. This is the story. A, B, D. Right? So D is the maximum point, B is the point where the two objects meet. We want to find this gap. This gap is the statement, first statement. So let me take this gap as capital H. So when the first object is at its maximum height, velocity is. When the first object is at maximum height, velocity is 0 meter per second. I want to find capital H. I want to find capital H. Capital H is the distance between D and B. So, to the first object, D to B, vertically downward, let me apply S equal UT plus half AT square. S is H. Sorry, the displacement of the first object from D to B is capital H. That is capital H equals lamai. Velocity of the first object at its maximum height is 0. Time is 1 second. Half acceleration. Now it is moving downward. Therefore, acceleration is plus 10. Time is 1 square of that. So capital H equals 0 into 0. 10 divided by 2, 5. 5 into 1 square is 5. So H equals 5 meter. So therefore, the statement capital A is correct. Am I right there? Statement A is correct. What about B? B. When x and y meet, velocity of x is 10 meter per second. Lamai, x means first object. What's the name of the first object? X. Name of the second object? Y. So what is the velocity of the first object when they meet? V1. How do you find it? Simple. A, no. D to B, D to B to the first object. What is first object? According to the examination, first object, name of the first object is X. Vertically downward, V equal U plus V. Velocity of the first object when they meet is V1. Initial velocity is the velocity at the maximum point, that is 0. Downward acceleration 10. The time taken for the first object to reach the point B is 1. 10 into 1 is 10. Therefore, V1 equals 10 meter per second. Therefore, statement B is correct. Statement C. Statement C. Whatever the time difference between the two ball projections, speeds are equal at the instant when they meet. Velocities are equal at the time when they meet. Correct. According to which equation? V square equals U square plus 2A S. Final velocity equal U square plus 2 acceleration minus G, height is H. So therefore V square equal U square minus equals to minus 2G H. So whatever the difference of the time difference, whatever value of simple T, both should have the same velocity when they meet, according to this equation. Got it here? So please write whatever the value of simple T, whatever the value of simple T, whatever the value of simple T, comma, the two objects should have the same velocity when they meet. Whatever the value of simple T, the two objects should have the whatever the value of simple T, the two objects should have the same velocity when they meet. Am I right? So you see, if you apply V square equal U square plus 2A, the V is same when H is same. They meet at the same height. Therefore, the height for the two objects same. According to this case, whatever the value of U, whatever the value of T, V is U square minus 2GH. It means, therefore, C is correct. So it means all A, B, C statements are correct. Now let's try to another MCQ. This is somewhat a new question. This is given in 2008 AL paper, MCQ paper. Some question, I don't remember the question now. 2008. Describe. Figure shows the variation of the force capital F. Please write the question with me. The figure shows the variation of the force capital F exerted by the flow on the feed, 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 with the time simple t, when a person jumps vertically upward, when a person jumps vertically upwards, when a person jumps vertically upward. Right, they have given us a graph like this. Could you please draw the graph? Force given by the ground to the legs of the man. That's easy, right? He is jumping up. At that time, legs are in contact with the ground. The force given by the ground to the feet is given by this graph. The force increases from 650 Newton to 1430 Newton. Time taken for this is 0.3 seconds. And a constant force of 1430 is given for a period of 0.1 second. So it means this gap is 0.1 seconds and the man leaves the ground. That's it. Draw the graph. Figure shows the variation of the force capital F. Please write the question with me. The figure shows the variation of the force capital F exerted by the flow, exerted by the flow on the feet, exerted by the flow on the feet, exerted by the flow on the feet, exerted by the flow on the feet with the time simple t, with the time simple t, when a person jumps vertically upward, when a person jumps vertically upwards, when a person jumps vertically upward. Right, they have given us a graph like this. Could you please draw the graph? Force given by the ground to the legs of the man. That's easy, right? He is jumping up. At that time, legs are in contact with the ground. The force given by the ground to the feet is given by this graph. The force increases from 650 Newton to 1430 Newton. Time taken for this is 0.3 seconds. And a constant force of 1430 is given for a period of 0.1 second. So it means this gap is 0.1 seconds and the man leaves the ground. That's it. Draw the graph. Below the graph, please write the force capital F increases. The force capital F increases from a value. The force capital F increases from a value from a value which is equal to the person's normal weight. Which is equal to the person's normal weight. Normal weight of 650 Newton. The force capital F increases from a value which is equal to the person's normal weight of 650 Newton to 1430 Newton in 0.3 seconds. In 0.3 seconds. The force capital F increases from a value which is equal to the person's normal weight of 650 Newton to 1430 Newton in 0.3 seconds, comma, stays constant force, stays S-T-A-Y-S, stays constant for 0.1 second, stays constant for 0.1 seconds, and then drop to 0, and then drop to 0 as the feet, and then drops to 0 as the feet lose contact with the floor. As the feet lose contact with the floor. Full stop. At what, full stop, at what speed did the person leave the floor? At what speed did the person leave the floor? Lamai, underline these words. Underline the words equal to the person's normal weight of 650 Newton. Underline the words equal to the person's normal weight of 650 Newton. Read the question from the very beginning. Do not answer. Read everything. So look at board here. Now the story is like this. When this man is on the ground, how many forces acting on the man? Tute. What are the two forces here? Gravitation attraction force mg and normal reaction force r. According to this equation, R is capital F. R is the force given by the ground and F is the force given by the ground. So it means R is capital F. Am I right? Alright. So initially what should happen? Initially R equals mg. R is F. F equals mg. R equals mg. According to the question, R is F. F equals mg. F is, I don't know. They have said mg is 650. That's the sentence that I have asked you to underline. I have asked you to underline. Normal weight is 650 Newton. Mg is 650 Newton. Initial force 650 Newton. So it means R is 650 Newton. It means mg is 650 Newton. So these are the things that you want to understand first. Weight Now this man presses the legs to the ground and get the more force. The force given by the ground increases. Look at both. The force given by the ground increases from 650 to how many Newton here? mg remains unchanged. This F initially 650. Initially 650. It increased from 650 to 1430 Newton. So what is the time duration for this here? 0.3 seconds. Okay, and this person is in contact with the ground for another 0.1. This person is in contact with the ground for another 0.1 second. During that 0.1 second, what is the force given by the grounding? 1430 Newton. Am I right here? So it says the force stays constant for another 0.1 second. Force will be 1430 Newton for another 0.1 seconds. Am I right? So initial velocity of the man is 0. After 0.3, after another 0.1, it means total time 0.4 seconds. He leaves the ground with the velocity of v meter per second. Question asks us to find what the v is. Okay, dear? Draw the figures. Right, look at board here. So what is the resultant force acting on the man? Now what? Resultant force acting on the man. Resultant force on the man is vertically upward F minus mg. Am I right? Upward force F, downward force mg. Therefore, the resultant force acting on the man is F minus mg. So, I have to do 3 calculations. Resultant force at the beginning here, F minus mg. So initially, look at board. Initially, what is F there? Stop right, please. What is initial left? 650. Initially, mg 650. Mg is always 650. Who says mg is 650? It is given in the question. That's what we have underlined. Right? So initially, at the beginning, when the man is at rest, upward force and downward force equal. Therefore, R equal mg. But question tells us R is F. F is the force given by the ground. So initially F, mg, R all are 650. Therefore, what is the initial resultant force acting on the man? By just looking at the board, you can say if R equal mg, R and mg cancelled out, resultant force should be 0. Am I right? Okay. So F is 650, mg is also 650. Therefore, the initial resultant force is 0 Newton. Complete. Listen here, no need, listen, stop. Just look at me. I am standing on the stage. What is the resultant force acting on me? 0. Do you want to do any calculation? No. But do a calculation and write. The next thing is resultant force after 0.3 seconds. That's fine. The resultant force after 0.3 seconds. How much? F is, this is F. Look at the graph here. According to the graph, F is 1430 after 0.3 seconds. Am I right? So that is F minus mg. F is 1430, F is 650, which is given in the question. If mg is 650, it is given in the question. I have asked to underline it. 0 minus 0, 3 minus 5 can't, we have to take 1. 13 minus 5 is, no, 13 minus 5 is how much? Hmm? 13 minus 5 is 8. This is 30. 30 minus 6, 7. 780 Newton. Okay. Right now, I can draw a new graph. Lamai. Now I am going to draw a new graph. Look at both. I'll draw a new graph. That graph shows the resultant force acting on the man. Resultant force acting on the man versus time. Initially, resultant force acting on the man 0. Resultant force acting on the man becomes 780 Newton after 0.3. 780 Newton after 0.3 seconds. And the resultant force remains, you see, this force remains unchanged, means resultant force remains unchanged for another 0.1 seconds. After that, the man leaves the ground. Draw this graph here. Draw this graph. Right, star point and right. Star point and right. Area under the resultant force. Area under the resultant force time graph. Look at both and right. Area under the resultant force time graph is equal to the change in linear momentum. Area under the resultant force time graph is equal to the change in linear momentum. Change in linear momentum. Change in linear momentum. So leave a line and write what is this here? What is the area under this graph here? This is, you can take a triangle and a rectangle, normally that's how you get. I don't use it as a trapezium. So I say half into base is 0.3, perpendicular height 780. That is the area of the triangle plus area of the rectangle. What is the area of the rectangle here? Length into length 0.1, height is 780. Normally I don't treat this as a trapezium. That's my way of it. But if you want, you can consider it as a trapezium. Change in linear momentum is mv minus mu. So 780, this is 0.3 can be written as 3 over 10. 780 divided by 2. 7 divided by 2 is 3. 1 remaining, 80 divided by 3, 9, 309. 0.1 can be written as 1 over 10 into 780. M can be taken out, remaining terms v minus u. Now, if M, look at what if mg is, we have limit 650, what should be m here? Mg is 10, 650, 0, cancelled out, m equals 65 kilograms. So mass is 65 kilograms. We can write that note later. Can you do the rest and find V? So what is this here? 0, 0 can be cancelled out. 3 times 9, 27. 3 times 3, 9 with the remaining 2, 11. 0, 0 cancelled out, 78. M is 65. V is the thing that we want to find. Initially, man is at rest on the ground. Initial velocity 0. 7 plus 8, 15. 7 plus 1, 8 with the remaining one, 9, 195. 65 times V. Take 65 this side. 195 divided by 65 equals V. So what is V here? Someone please tell me. Is it 3? 5 times 3, 15, 1 remaining. 3 times 18 with the remaining one, 9. Yes, correct. 3 meter per second. Who got this answer? So this is how to explain the question, but this is not the way to answer an MCQ. This is just a way to teach, to explain. I'll explain how to do this as a MCQ. First you read everything, check whether you can understand them all. After that, I'll tell you how to do this as a MCQ. Right. The method that we use in MCQ paper, his weight is 650 Newton. So even the force is 130 Newton, 1430 Newton is given upward, 650 is cancelled out. When there's a force upward, when there's a force 1430 upward, there's a downward force of 650. Therefore, cancelled out. So forget about this section. This entire 640 section is cancelled out, useless. It does not affect the case. Only the effective case is the red color shaded area. This is the effective force. This is cancelled out. This section cancelled out by the weight of the person mg. So now you want to consider only the area of this section. What is the area of the effective section here? Half into base. I'll consider this as a trapezium. Half into sum of the parallel sides 0.4 and 0.1. Sum of the parallel sides 0.4 and 0.1 into the perpendicular gap between the parallel sides 100 and 1430 minus 650 is the gap between the parallel sides equal to MV minus MU. So this is how you want to solve this question in the exam. Can you shade like this and mark effective and write this answer?